this, our life becomes increasingly full with games. If you ask adults 20 years ago how many people play games, you may not have, you wouldn't have seen as many hands. Okay, so let me start by introducing some entities here. This interest group that we started in 2009 is a group of people who do reviews of mathematics education communities, informal communities and projects and online groups. So some of you presented for it, or some of you participated in different ways. And a big interest within this group is the game group, where people are interested in developing games about mathematics. So this computer does not want to do my Yahoo pipes, which aggregate different content here, where you see the big spot. But there are people in this group who can research mathematical game mechanics and who study how to make games that are intrinsically mathematical and fun. So my game that I'm developing right now is called Math Track. And the mechanic of this game is noticing mathematics in all contexts, which all of us do and enjoy. It's something fun where you see the Fibonacci sequence in where it is or where it isn't sometimes, or where you notice tessellations in architecture, whether people intended them or not. So what is alternate reality games for the rest 95% of you who haven't heard of it, or however what it was? It's the type of the game where you use some computer or virtual world or cell phone technology to interact with virtual entities. Virtual entities can be, well, mathematical models. That can be information that's in the computer, can be labels or tags, can be some social comments on things. And at the same time, you use reality, physical reality of this world to play with. So I'd like to give everybody about a minute to kind of think to themselves and talk to their neighbors at the table and come up with some examples of games that are like that, where you interact with some computer entities and interact with some physical entities within one game.
Well, the IRS
Anybody want a napkin?
Yes, I would like that. I wonder if that's thanks. I guess I know that's great. I'm going to describe it.
We were talking about one other model right after the something about whether or not, like how to allocate points when the other team had a different solution.
Yeah. The thing is that, right, it actually says that against the solution. Now, what is what happens if
Okay, so this is what I do at my math clubs. It doesn't involve me. Okay, I know this conversation can go on for a while, and I hope it continues. Oh,
I thought it would be easier.
Okay, people's attention. Okay. So basically, I hope you continue this conversation because it's an interesting conversation. I could see from the level of sound in the room. So I'll just point at the table. You name one game that you came up with, okay? It was still interesting conversation.
Dan told me about something that boggles my mind where you want to say what it is, I can't say it.
Well, there are these sort of next generation games in which you're not just sitting at a terminal and entering a world through your computer, but you're actually taking, let's say, your cell phone or some device, and you can go out into the world and see a mixture of the real world and a virtual world which is superimposed on it.
This is exactly an example. This is done in museum, for example, where you walk to a piece of art with your computer and you see comments of previous visitors, for example, or you see some information, or if you are in a class, you can see only information related to your class, what your class members did, if you choose that. And as you walk to the next piece of art, you see the next thing, because your phone knows where you are. So, for example, that's a very good example, okay?
Foursquare?
Foursquare, who plays Foursquare? Okay, a few people know. Can you explain it briefly?
That's where you check into various locations using your smartphone, and you're rewarded with various things.
Have you ever been a mayor?
No, I have not.
How about you?
No, I thought he was talking about the elementary school game.
Okay.
Oh.
I did too.
Yeah,
Don't worry,
yeah.
I did.
Okay, this is a grown-up game where you play with, you interact on your cell phones with people around you. The game knows who plays in the room without you explicitly telling it to. So you can gain various positions within this group and play like this. Okay, how about this game?
Second Life?
Second Life. Okay, how is it? Who knows Second Life? Who knows about Second Life? Good distinction. How is Second Life connected to the physical reality?
There's real money being exchanged for non-real things.
Is money physical?
Okay, never mind.
Okay, and this is a very good illustration of how the lines just blend. You can't really distinguish one type from another really easily at all. So yeah, there are no boundaries. Usually, traditionally, when people talk about alternate reality games, they mean some physical, spatial metaphors being employed as game mechanics. Moving in space, doing something in space, interacting with your space position. However, there is nothing that says the definition has to be that narrow. So, Second Life is an amazing thing in many different ways. Okay, how about you guys? No?
Also Second Life. In Second Life, you can construct models of real life buildings. Like you can build campus, just like the real life campus. You can even build a classroom, and then do the actual teaching and learning in the classroom.
This is a beautiful example. Thank you, this table. This example is of how people build models of physical objects in virtual worlds. And then, even though there may not be a direct interaction between this table and the virtual table in Second Life, the correspondence is such that people can interact meaningfully with physical and virtual space kind of in the same setting. There are islands for schools in Second Life, for most major universities actually, and for a lot of projects. Okay, thank you. Okay.
Would you consider geocaching to be something that falls in this?
How many people know geocaching or of geocaching? Okay. Can you explain it?
Well, actually, someone else could probably explain it better. Maybe I could pass this to someone who's actually done it, for example.
I did it once, a couple times.
Okay.
There's some hidden treasure somewhere on a latitude and longitude spot, and your phone or your what's it called? GPS knows where it is, and it keeps telling you it is such and such a distance northeast or southwest from here, and you actually have to walk in the physical world until you get to the location, and you find the little box that somebody has left there. And you can take out something and put something in and sign your name, I've been here.
There are the more mathematically interesting steps there sometimes involve puzzles. It doesn't tell you directly where to go. You have to take the location information and solve a puzzle with it to figure out where to go, kind of like old-fashioned pirate maps. So you have to find something, solve something. Some of the, that I would consider it, do you think it's reasonable to consider it AR3? Because it has physical and virtual parts. There are Eastern European games, they're called extreme city games, that are kind of geocaching with adventure in physical space. A lot of puzzles involve climbing or going into abandoned factories, finding things, and occasionally races and chases and stuff like that. So people can take it in different directions. That's a very good example of such a game. Okay, I think I'll take maybe a couple more examples and move on. So how about this table?
Rock bands?
We. Who knows we?
Oh,
okay. That's great. So that's obvious. And now Kinect, where you don't have to hold the thing, you can just gesture. So I'm coming downstairs one day and see my husband doing this. And he was playing Warcraft actually. Because he hacked the Kinect to talk to the computer and to play, to do computer interface with the body. Okay, how about this table?
We came up with score and crayon physics.
Crayon physics. How does it connect to the physical world?
Because it models the laws of mechanics.
Okay, so this is another kind of definition thing where do you consider the model connection, or do you have to do something in the physical world to interact with the game for it to be a connection? That's semantics there, we're not going there, but these are interesting modeling examples. Okay, you have an example there?
We also thought of geocaching.
Geocaching?
I thought of the
We? No? Okay. Okay, so we have some examples, and I think people from examples at least can know what the game is. So the game we are playing in one of the math clubs is based on photography and aggregating pictures, but not in mathematics. So the mathematics is in what we do and in what we understand. Okay, here's our game. And the reality is that we physically go around the town or museums or some interesting places and find mathematics there, and then we upload it. So here is our site. There are some game levels, and here is an example of a game piece that I give students. So that's sort of the mechanics there are scavenger hunt and finding mathematics. Kind of, I tell my people, you grow your math eyes for your game. And this is a very rewarding where people suddenly start seeing tessellations everywhere where before they weren't aware. People find this rewarding, so that's a game mechanic that you can use to design. So these are playful and they can get role-playing, so I'll scroll down to the one that's more role-playing. That was about Harry Potter, so he who must not be curved, stuff like that. And you invite people to design this, so after the first piece, the mathematics and some of the quests, these are quests were designed by people from the group, by parents and kids, suggested, well, changed. So, and then we have this slideshows, that's a virtual part of it, where we have a Flickr group and people upload and tag there. So these are pieces that just go with this particular meeting that we had. And there are different things that people found, so this is that curve. And we talked about curvature, and somebody found different things, so some different ideas. And people found the curves. They were throwing stones for a while there to take this picture. They were picking stones. So sometimes people climb into things to take photographs, and they find signs. And then months later, little kids would come to me and say, "I found such interesting curve," or whatever it is they find. They start noticing things. So that's kind of the point of exposure. And of course, if they're interested in the topic, then we go into more formal. What makes one curve curvier than the other? What will this curve end up intersecting with? Yes, that's me. Climbing there. So that was an example of design. Now I would like to program it now that the proof of concept happened, and we know kids really love it and parents really love it and so on. Next time is, okay, 2 minutes, okay? So the next step is to program the interface for it. That's a bit easier than what we can put together on Flickr and Wiki, and that was at the museum, and about angles. Something easier than we can put together out of free available tool. However, the point I want to make is, out of free available platforms and tools, we put together a working game with no programming and no platform building and very little time really. So right now, I couldn't do it 5-10 years ago. Right now, you can do a lot of game design just using what's available freely. And so there are communities for game designers. Gameful is probably one of them. There are some math people there. There is the group we formed of that. There is Gamification Encyclopedia, which is and gamification people, which is a slightly different direction, but it's still relevant. And of course, coming back, there is this interest group where we discuss things like that and have presentations from math game developers and people who are interested. Well, the next one will be on April 11th with Keith Devlin about his vision of math games. And we usually have some game people every month or so at least. So thank you very much. I hope you develop more math games or play, because a lot of